5 clusters. Yeah, so we'll generate 5 clusters. So you'll see, actually, if you have 5 clusters, still one major cluster will have more than 1,000 files, and basically just splitting the other smaller cluster, right? Okay, so this is basically k-means. So if you want to do a hierarchical clustering, okay, so first you need to define a distance measurement. So first of all, I just use a Euclidean, right? So H class, so method you can say I want word. Okay, so basically, if you want to, so yeah, so since each class you can, hierarchical cluster you can see it, so you can plot it. My heart just crashed. So basically we plot central graph, okay, for the hierarchical cluster. Yeah, so if you want to say I want to cut it to 5, then it will cut to 5. Then in groups, you will see which groups is it. Okay. That's clear? Alright. Yeah. So I think for clustering, so there's a lot of things you can tweak, but the command and the process is very simple. So there's not a lot of things that you can do for, you want to be careful about as in the modeling. And so modeling, you have to pre-process a lot. Okay. So actually, because last time in modeling, we only show like a regression, a logistic regression model, right? There's other modeling techniques, so I want to show all of them, or maybe a part of them. Right? So one of them is people use a lot is random forest. So this is a lot more accurate and a lot more widely used than, for example, logistic regression. Right? So random forest is basically you will build a lot of small trees. Based on your data, it will build a tree and say, if lines of code is bigger than 500, goes to this way, smaller than 500, goes this way, and this will say, if a complexity is bigger than 2, it's buggy. Otherwise, no buggy. Bigger than 500, buggy. Okay? So first you build a small tree like this. Then you will randomize the data and build a large number of these small trees. Okay? So you can tell random forest, I want 500 trees, I want 2,000 trees, right? So random forest will build 500 of these. And when you have a new data, when you do prediction, you will do a vote. So for example, if you have 500 trees, and you vote yes or no, buggy or no buggy, so the majority gets the vote. So this is very robust, right? So you don't really have to understand how random forest works. So all you can remember is basically it's a more advanced, a more robust technique to give you a prediction. Okay. So if we have the same stuff from last week, so basically. Basically, this is the line. Okay, so basically it says it's random forest. What's the data? So this is the data I give him. What's the outcome of the data? So the outcome is whether the post-release box is bigger than 0. How many trees? So I set 100 here, right? So because this one is very slow. Because you build, if you tell him 100 trees, you will actually build 100 trees. Basically build 100 small models, right? So typically people build like 500 or 1,000. Tell him, oh, this is a classification, and I'll come back to the importance later, right? So after you do this, move on. Okay. All right. So yeah. So basically, this is the random forest. So if I so basically, this tells the random forest. So how do you know how good is a random forest? So there's no R square. Because this is not a statistical model, right? So for a statistical model, essentially you're trying to feed a line, right? So for example, if you have data points on here, you want to do a regression, basically you're trying to feed a line. So R square is basically the dots, how far is the dot to the line. If your dots are all on the line, you have a perfect fit. Right? So this is the classifier. So this classifier, there's no dots, there's no R square, right? So how do you know how good is your model? So basically the only thing you can do is precision recall, right? So basically you do a prediction and you say what's the precision recall, right? So I'll cover the predictions from next week. Okay, so for now, just hold on, right? So for now, in your mind, random forest, there's a way to evaluate how good it is, but we haven't shown it yet. It is basically through precision recalls, right? But now, because we build the models with a purpose, right? So why do we build a model? We build a model to want to know which metric is more important, right? So in our prior weeks, we want to know which metric is more important to bug, right? So everyone follow this? So we want to know either is the lines of code more important to a bug, or is a parameter bug more important to a bug, or is a person more important to a bug, right? So we want to know that. So how do we know this? So in random forest, there's something called variable importance. Okay, so what is variable importance? So I'll just show you the command here. So the command here is basically it will tell you for every variable how important the variable is. Right? So the bigger the value, the more important the value the metric is. So how is this variable importance calculated? So it's basically based on this logic, right? So basically it's saying if this variable is very important, right? Then if I replace this variable to garbage, then your model will become also garbage, right? If I replace this variable to garbage and your model is still good, that means your variable is useless. Everyone follows this logic? Okay, so basically what it does is we'll pick one variable, replace the variable's value to random values. And you see how many prediction errors your model produces. Then this variable importance, this percentage is based on that value. Right? So check how many times, how often, because you replace the variable, keep up. So this is only on one variable. So all other variables keep them as the true value, the generating value, right? So only one variable you replace it by random value. Then you see how many times you gave a wrong prediction. Okay, so the more often You give a wrong prediction, that means the more important is your variable. Okay. So this technique, you can use this not just for random forest. It's actually you can use this for any variable assessment, right? You want to ask something or?
Yeah. Actually, we wanna first do that and then build the model, or
Afterwards. So after you build the model. So after you build the model, because okay, so here there's no p-value, right? So remember when we build a statistical model, first we build a model, there's a p-value, right? So everything that's p-value that's not significant, we remove it. We only keep the ones that's significant in the model, right? Everyone understand? Everyone remember this process? So first we after correlation analysis, we have a list of metrics. We build a model. After we build a model, we see the p-value of each metric in the model. If the p-value is bigger than 0.05, we throw away that variable, that we rebuild the model. So that's our final model, right? Everyone follows me, right? So this one, there's no p-value, right? So you cannot throw away stuff. So basically, but the good thing is these classifiers, they are very robust. So you can keep them in it. It won't impact much, but afterwards you will need to say, hey, is this one important or not?
and how do we calculate this importance?
So you mean in practice or in R?
I mean, for example, is this information gain, something like that, or?
It's not information gain. It's basically you will do a prediction. So we'll do a prediction with your real value, and you will do another prediction with random value, and you see how much of them do not match. Yeah. So the more they do not match, that means the more important you are, right? Okay. So at least this one, you can give me the information, right? So tell me, basically major actors. Major actors play a big role, right? In here, and also size, right? That's not supply, right? So prior box, right? You see. So the findings are like the results are very similar to, I would say, to the logistic regression model, right? But on the other hand, so this one can give you a much accurate prediction than a logistic regression model, right? So there's one thing missing. There's still one information that's missing by this. So you don't know the direction of the impact, right? So this one only tell you by replacing size with a random value, you have a large influence, right? But it never tells you the influence is positive influence or negative influence. So it won't tell you whether the size is, the bigger the size, the more body, or the bigger the size, the less body. So this information is hidden in random forest, right? Because again, so this is a classifier. So classifier only tell you what is what. It won't tell you this one goes up, this one goes down. Right? It's not a statistical model. Okay. So one good thing about this is naturally can handle categorical data. So in regression, all the input needs to be numbered, right? So basically you're doing a calculation, right? So everything needs to be a number, but in here, it doesn't need to be a number. You can have a categorical value. And so naturally you can just dump it here to give you a categorical value and do the prediction, do the model, that's fine. Questions? Anything
So is there
unclear about
a way
this?
to know the direction?
So normally what people do is after you get this, right? For the important one, for the very important ones, for example size, just do a t-test, right? Or do like a Wilcox test. From the Wilcox test, with or without bug, you know which one is higher. If the buggy one has a higher size, probably the direction will be positive. So that's the typically people do this, but you cannot really. So maybe something different, like you don't really know. So there's two different things, right? Two different pieces of information. But in most of the cases, this is okay. Questions? Concerns? Okay. All right. So basically, so next week we'll cover prediction. Okay. So after prediction, I think that's all I want to teach by this class. Okay. So maybe we'll do the yes.
So I have questions about our project.
Okay, yes, sure. We can discuss the project first. Then we do the quiz.
So sir,
So maybe let me pull out the paper so we're on the same page. Okay, so what's the question?
Okay, at the fourth page for the metrics, the post-release defects. Yeah. Sir, I still don't get how we use these IDs. Do we already know these IDs are related to post defect?
So you have an ID
Okay, how do we get those IDs?
from commit message.
So we have to just go there and decide which one is associated with defect?
No, it's okay. So I'll go through this again. So for commit, for example, for Hadoop, this is a commit message, right? Okay, so again, if you don't understand, ask me right now. Okay, so if you don't have this data, there's no way you can build a model. Okay, so for Hadoop, for example, you have this commit message. From the commit message, you write a regular expression to extract this part. Hadoop -15925. With this part, you make a web call. The web call one five nine two five. 1592. Okay, where's the web call? One five nine two five. You do this web call. Everyone knows what's going on. Okay, so in this web call here, there is a type. Here, see. If there's a bug, okay, so then you know this issue, whether this issue is a bug. If this issue is a bug, that means that change is trying to fix that bug. So now the question is whether the bug is a pre-release bug or post-release bug. Then you need to know when is this one created. This one is created November 13, 2018. Okay, and this bug is trying to fix these versions, right? Make sense? So now the question is, are these versions before this date or are these versions after this date? If the date is after the release of these versions, it's a post-release bug. If this date is before the release of these versions, it's a pre-release bug. Okay? Okay.
And sir,
Yeah. Huh? Well, you have to you need to pre-specify what version you want to study. So if it's not, so for example, you say I want to study Hadoop 3.0, then you only care about this, right? You don't care whether it's a post-release for 3.3, right? So you need to pre-specify what's the subject you're going to study.
And if I have a specific version to keep,
Yeah.
and I just check the create time.
Yeah.
And what if I don't find it in the list of the versions?
Then you just ignore the bug, because that means that bug is not associated with your release.
So has nothing to do with this version.
Yeah. So you only get the bugs that are associated with your release. Right? But normally you do a major release. You do not do a minor. So you do something like a 3.0.x. So anything that's 3.0 point blah, you consider that as 3.0. But if you do a 3.0.4, you may have like 10 commits. Or I don't know, very small size of data that there's no way you can do.
So you're referring like we should do for like 3.1 or 3.2.
Yeah, like
or
a major
is it
release.
directly 3 or 4.
Yeah. Yeah. Either way, I think 3.0 point something, 3.1 point. That's depends on how much data you really have. Okay, so there's a case maybe you don't have enough data, but I think if you just do 3.2 point something, 3.1, so keep two numbers, that's okay. So the last one is very minor, so just throw that one away.
In general, how many bugs we need to have? Like this is example of one bug.
It's not about how many bugs, it's actually how many, well, you need to check how many files you have, right? And in part of that files, you want to see how many bugs, how many files are buggy in that period, right? So if there's very few files that are buggy in that period, then there's no knowledge, not enough knowledge. So at least you want to see something like 20-30%. Right? So if you see like less than 10% of files that's buggy, that's very hard. You can still build a model. The problem is the model will be very bad. The more information you have, the more information, better model you can build.
So we shouldn't choose high quality software.
Well, the high quality software, that means the less bug. The less bug, the harder to predict. Okay. So for example, okay, let me give you an example. So if we live in California, okay, and we want to predict when do we snow, it's very hard to predict it. Because you only snow like, I don't know, 1 day per 10 years. So the more rare the event, the harder you can predict it. And the more often the event, it's easier to predict it.
Actually, it also depends on the size of community and maybe maintenance efforts sometimes, because people don't use that product, the bugs are
Sure.
not discovered.
Yeah, but then I think it's mostly is the proportion of the category. So in another way to say this, so the more unbalanced data, the harder to predict. The more balanced data.
If you want to find the version 3.0.x,
Yeah.
and to find the created data, it's between 3.0.1 and 3.0.4.
I would say that's still a post-release for 3.0.0. So basically, you want to see you want to set the release date as the 3.0.0 or 3.0. Basically, the first release of 3.0 point something. That's clear?
So for doing this, we have to do screen scrap.
Well, you have to write a script
Yeah.
to parse this. Yeah, Python, Perl, Ruby, whatever you want to use. Yeah, people use R to do this.
Does R have anything to do with this?
You can, but you're looking for trouble for yourself.
Yeah.
I think Perl. Yeah, if you know how to do Perl, this is like, I don't know, 5 lines. Questions? Any questions about project?
And sir, for the budget,
Yeah.
the 15, we have to base this budget with the files with bulk. Is that correct?
No, the total.
The total
The
number.
total, yeah. The total number of files. Other questions about the project? So I assume no one have any issues with the product. You know what to do. Yeah.
This is a way to get the release, the commit, and then besides we need to use understand to analyze the code.
Yeah.
So this, if we choose, for example, we choose 2.920, and we need to use the understand to analyze the
2.920. Yeah.
and we get matrix,
Yeah.
and we find if there is some matrix corresponding to the box.
Yeah. Okay, so let me see if we have enough. Okay, so this is understand, okay? So let me me see if I have some source code here. Okay. So I'll just simply show you how to do this. Okay. So this is understand. So if you don't understand, okay. So then you have a new project. Yeah. Okay. So then it tells you. So this is study. So this is the folder. So I just put my container folder here. Let's say next. You will care about Java. Next. Nothing. Something's wrong. So you should load all the files here. No idea. It's here. Add a directory. Oh, okay, it's here. Okay, so basically open this. You say, okay, I want to add a directory. I add this directory. So this is the user, my name, Cassandra source. I only care about Java files. So Java files here. I'll go next. Then say this is begin analyzing the project source. And boom, we start to analyze. I think something like this will generate. This is very slow. I don't have a fast machine. Yeah, something like this. You see this is file. What's the path of the file? Cyclomatic. Cyclomatic. See all those metrics? Is this easy? Okay. It's 2 minutes, literally. Okay. Other questions? Yeah, but you have to download understand. So so understand has a education version, something like that. So you just tell him you're a student in Concordia, they give you a license. So it's a free forever. Questions about project? That's it?
Sir, I have another question. For the email addresses, so you have to just know how many email addresses is associated with each file? Or
Basically, yeah. So the simplest way you can consider one email address as an author. Yeah. So yeah, for your product that's fine. I think that. So normally people have to say these two email addresses are from the same person, but I think that's too hard for you guys.
Okay, and for the total number of changes for the change metrics, you just have to see how many changes happened to this file during its existence.
During the pre-release.
Pre-release.
Pre-release period. So from this release to the last release.
to the last release.
Yeah.
That's it. Not,
Yeah.
not from the starting time.
No, not from the start. So if you care about the second level release, for example, 2.9 point something, right? So then you check that day to 2.8 point something. So 2.8.0 to 2.9.0. So that's your pre-release. So anything after 2.9.0, that's the post-release of 2.9.0, right?
Changes when the bug has been closed, right? The bug or the issue has been closed. That you consider as a change.
No, the change is the file level. So basically, how often the file is changed. Question? Okay. So again, so if you have any questions, you can always send me email.